Hey everyone, in this video we'll learn about inequalities and we'll learn how to write them on a number line and how to use interval notation. So first of all, what is an inequality? So let's talk about equations first. So equations, 3 equals 2 plus 1. An equation has an equal sign right here. And if you go ahead and evaluate this, 2 plus 1 is 3. So 2 plus 1 is 3. 3 equals 3, which is a true statement. So equations, if you just write it out, equations, and then equal, you can almost see the word equal in there. And that's what makes an equation an equation. There's an equal sign in it. Now an inequality, on the other hand, so inequality, so you can also see the same root in there. You can see the word equals in there actually, equal. But then you see this in the beginning, which means not, so not equal. So not equal. So inequalities, we don't use an equal sign. So for equations, we use an equal sign. But for inequalities, we have various inequality symbols. And let me write some of them down. We have a greater than, a less than, a less than or equal to, a greater than or equal to. These are the inequality symbols that you'll see. And just to show you what an inequality looks like, just an example, 3 is greater than 2. So how you read this is 3 is greater than 2. And this is a true statement. 3 is greater than 2. Now, can I write 2 is greater than 3? Well, I can't. 2 is not greater than 3. 3 is bigger than 2, so this doesn't work. So this inequality right here is invalid. That's not true. So just to go over the inequality symbols again, we have greater than, less than, greater than or equal to, and less than or equal to. So what do these mean? Greater than or equal to and less than or equal to. So if we go ahead and write 3 is greater than 3, again, this is false. 3 is not greater than 3. 3 isn't bigger than 3. 3 is the same as 3, so this is false. But what if I write instead 3 is greater than or equal to 3? So 3 is greater than or equal to, well, it's not greater than, but it is equal to, so this is true. And that's the main difference right there. This bar under the greater than symbol can mean or equal to, so up until 3. So 3 is greater than or equal to 2 is also works. Now 3 is greater than equal to 3. That also works. But 3 is greater than or equal to 5. That doesn't work because 3 is actually less than 5. So that's how you use the inequality symbols. And let's go ahead and solve some inequalities with variables in them. So we've solved plenty of equations that have variables in them. Let's go ahead and do the same thing with inequalities. So let's say down here, we have 15. So we have 15 minus 10x is greater than or equal to 11x plus 1. Okay, so 15 minus 10x is greater than or equal to 11x plus 1. How do we solve for x? So this is an inequality, and just like with equations, we also want to solve for our variable x. So we do the same thing that we would in an equation. We are going to isolate x. And how we can do that? Well, we have a positive 15 here, so the opposite of that is negative 15. So negative 15 on both sides. We are left with negative 10x is greater than or equal to 11x plus So plus 1 minus 15. Plus 1 minus 15, you can combine those. That's minus 14. So this comes out to minus 14. And we can keep going. To further isolate x, we could bring this 11x over to the other side of the inequality. So the opposite of positive 11x is negative 11x. So negative 11x both sides. Negative 10x minus negative 11x is negative 21x. And that's greater than or equal to negative 14. And we're almost there. We're almost there to our goal of isolating x. All we have to do is get rid of this negative 21. So negative 21 times, we can go ahead and divide by negative 21 on both sides. And we have x. And on the other side right here, what is negative 14 over negative 21? Well, the negatives cancel out, so negative divided by negative is positive. So 14 over 21, so 14 over 21. We can also simplify because they both have a factor of 7. So if we divide the top and bottom by 7, that will give us 2 over 3. So 2/3. 2/3. Let's go ahead and write that. So 2/3 is what that fraction simplifies to. And now check this out. We have this greater than or equal to symbol here, but this is not true. We have not solved this. We've missed one step. And the thing is, we have divided at this step right here. Take a look. We divided both sides by a negative number. So look what happened on this side of the equal sign, or my bad, on this side of the inequality when we divided both sides by a negative number. This was originally a negative 14. And the answer became positive. So it went from a negative number to a positive number. So as a result, we actually have to flip this inequality right here. It's no longer greater than or equal to. It's going to be less than or equal to. And the rule is that if you multiply, so on both sides of the inequality, if you multiply or divide, so if you multiply or divide by a negative number, then you have to flip the inequality sign. That's the rule. If you multiply or divide by a negative number, any negative number at all, you have to flip the inequality sign. And let's just go through a mini example. Let's say we had negative 2x is greater than, so negative 2x is greater than 2, let's say. Well, to get rid of the negative 2 and isolate the x, we can divide both sides by negative 2. And what does this come out to? This comes out to x. And then we have to flip this. We have to flip this greater than symbol to a less than symbol. And what's 2 over negative 2? That is negative 1. So x is less than negative 1 would be our answer in this little mini example. So that's the important thing. It's very similar to solving for equations, but the only rule you have to watch out for is on both sides when you're multiplying or dividing by a negative number, you have to flip the inequality symbol. So this would be our answer for this inequality. X is less than or equal to 2/3. So that's how you solve an inequality. And now let's go ahead and talk about number lines real quick. So we have this inequality right here. X is less than or equal to 2/3. How do we represent this on a number line? Well, what we want to do, let's go ahead and draw a number line right here. And let's draw it in segments of a third. So instead of going 0, 1, 2, 3, just to make it easier, let's go a third, and then 2/3, and then 3/3, which is actually 1. 3 over 3 is 1. And then this is 4/3, 5/3, etc. And we could do it on the opposite side too. Negative a third, negative 2/3, negative 3/3, which is 1, and then etc. So we drew a number line. And how do we represent this answer up here, x is less than or equal to 2/3 on this number line? So what we're going to do is we're going to find 2/3. So we're going to look for this 2/3, and it's right here, 2/3. And next is we're going to draw a circle right above it. So we're going to draw a circle. Now, is the circle going to be open or closed? So let me tell you, this is an open circle, and this is a closed circle. The circle is filled in if it's closed, and the circle is not filled in if it's open. So basically, you have to look for this bar under the inequality. This is a less than or equal to. So if it's a less than or equal to, so if there's a bar, then you fill it in. It's a closed circle. And let's say there wasn't any bar there, then it would just be an open circle. But in our example, there was a bar, so we will make the circle closed. Okay, now I drew a circle. What else do I do? So x is less than or equal to 2/3. So what does that mean? Which direction do I point an arrow at? So just go back to 2/3 right here and look on either side. You have 1/3 over here, and you have 3/3 or 1 right here. What number is less than 2/3? Well, right here, 1/3 is less than 2/3, so I want the arrow to be pointing this way, to the left. So we will draw a line with an arrow going all the way to the left, and that is how we represent this answer right here. X is less than or equal to 2/3 on the number line. And what this is supposed to represent is every number along this green arrow, so 1/3, 0, negative a third, negative 2/3, x can be any of these values anywhere along this arrow, and that will make our original equation work. This right here, 15 minus 10x is greater than or equal to 11x plus 1. So that's how that works. And let's also talk about interval notation. So x is less than 2/3. How do I represent this using interval notation? So right here, as we could see on our number line, what's the lowest possible value that this could be? Well, if I go all the way to the left of this number line right here, it looks like the arrow goes forever to negative infinity. Okay, what's the highest possible value this can be? Well, if I go all the way to the right, the highest value it could be is 2/3, right here. 2/3, 2/3. So it looks like it can go from negative infinity all the way to 2/3. And how you represent this on using interval notation is whenever you have interval notation, you are either going to use parentheses or brackets. So what this would look like in interval notation, we'll use a parentheses. Negative infinity is the lowest value, comma, and the highest value, as we said, is 2/3. 2/3. Now, whenever you're dealing with infinity, you're always going to use a parentheses. So the difference between a parentheses and a bracket is the parentheses excludes the number you're talking about, and the bracket includes the number that you're mentioning. So whenever you're dealing with infinity, you always use parentheses. So infinity and negative infinity, they always use parentheses. But now we're dealing with this number, 2/3. Well, our circle is closed. So if our circle is closed, that means we're including 2/3. So we're going to use a bracket. And that is how we represent our answer using interval notation. And just to contrast it, let's say our answer was instead x was less than 2/3. So without this greater than symbol down here, let's say that greater than symbol was gone. How do we express this using interval notation? Well, again, the lowest number it could be is negative infinity. And the highest number it could be is up to and excluding 2/3. So it's still 2/3, but you put a parentheses here because you don't put a bracket because 2/3 itself doesn't work. Because if you go ahead and try to plug 2/3 into this inequality, 2/3 less than 2/3, that's not true. 2/3 is not less than 2/3. That is simply false. So we have to use a parentheses here if there's no equal bar under the inequality. This is not less than or equal to, this is just less than. So that's how you would represent it in this case, right here. So let's go through one more example together. Let's say we had right here, negative 3x plus 4 is less than 0. And again, our goal with this inequality is to solve for x. It's to isolate that x. So let's go ahead and get rid of this positive 4 by subtracting 4 from both sides. And we have negative 3x is less than 0 minus 4, that's negative 4. And then to finally isolate this x, we will go ahead and divide both sides by negative 3. And look, we divided a negative number on both sides. So that means we have to flip this less than to a greater than. So this will become a greater than. And what's negative 4 over negative 3? The negatives cancel out if you have them both in the numerator and denominator, so we could just leave this as 4/3. So 4/3 is the answer to our inequality, or x is greater than 4/3 is the answer, is how we solve for x. And let's go ahead and just write it down on a number line. So let's draw a number line. Let's put 0 in the middle, and let's go 1/3, 2/3, 3/3 is just 1, and then 4/3, 5/3. And then on the left, we could go a little bit. We could go negative 1/3, negative 2/3, negative 1, etc. And etc. on the other side. So the last number, or not really last number, but this would go all the way to negative infinity on the left. And on the right side, it would go all the way to positive infinity. Okay, so how do we draw this on a number line? Let's go find 4/3. It's right here, 4/3. And let's go ahead and draw a circle. Is it going to be open or closed? Well, that depends. We have an x greater than. It's not a greater than or equal to. If we had that or equal to, it would be closed, but it's just a greater than, so we'll leave it open. And we're going to draw an arrow either to the left or to the right. So which way are we drawing this arrow? Well, this is an x greater than. So if it's a greater than, well, what's greater than 4/3? 5/3, 6/3, 7/3, etc. And all those numbers can be found to the right. Usually the right has the greater numbers and the left has the lesser numbers. So that is how we draw our arrow on the number line. And then let's represent the solution set using interval notation. So again, let's go ahead and find the minimum value. What is the lowest value that the solution set could be? So just look at our arrow. And the lowest value on this arrow, well, our green arrow goes up to this 4/3 if you go all the way to the left, but it doesn't include this 4/3. And that's fine. We can write 4/3, but we will put a parentheses. we won't put a bracket. We'll put a parentheses if the circle is open, but if the circle was closed, so if the circle was closed just to show you, then we would put a bracket. Bracket 4/3. But in our example, the circle was not closed, so we'll leave the parentheses there, and then comma. And then what's all the way to the right? Well, it just goes to infinity. So we will put infinity, and then infinity you always put a parentheses, because you can never get up exactly to infinity, because infinity just means never ending. So that is how we represent our answer in interval notation, 4/3, comma, infinity, both parentheses. So that is how you solve inequalities, that's how you write them down on a number line, and that is how you use interval notation. So I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.